May 8, 1942. The USS Yorktown is burning. A Type 91 torpedo, weighing approximately 1,170 pounds and packed with 352 pounds of explosive force, has just ripped through her starboard side, and this ship is going down. At least, that's what everyone topside is telling themselves. The Japanese believe she's finished. The torpedo has torn a hole so massive that seawater is flooding compartments faster than any damage control team could possibly manage. But they don't know what's about to happen below. They have absolutely no idea that there's an entire crew of American sailors, men whose names would never make the history books, men whose faces would never appear in the photographs, about to perform something absolutely extraordinary. These men aren't pilots. They're not commanding officers barking orders from the bridge. They're the repair party. And what happens next over the next 30 minutes will determine whether the USS Yorktown lives or dies. Most people, when they think about naval combat in World War II, they picture the big moments. They picture pilots engaging enemy aircraft. They picture massive naval guns firing salvos across the ocean. They picture explosions and chaos on the flight deck. What they absolutely don't picture is what happens below decks, in the cramped, suffocating compartments deep inside the ship, where temperatures are climbing past 120 degrees, where the air is thick with smoke and steam, where visibility is reduced to almost nothing. That's where the real battle is happening. That's where men are making split-second decisions that will either save their ship or seal her fate. The repair party isn't some elite unit. These are regular sailors, machinists, electricians, damage control specialists, men who trained for this moment but never truly expected to face it in actual combat. They're working with information that's fragmentary and incomplete. They're operating in conditions that are absolutely unbearable. They're racing against physics itself, against flooding, against pressure, against the fundamental laws that say a ship this badly damaged should simply sink. But they're also working with something else. They're working with American ingenuity. They're working with a level of organization and training that their Japanese counterparts absolutely didn't expect to encounter. This isn't about heroic last stands or glory or names that echo through history. This is about professionals doing what they were trained to do under circumstances that push every single one of them to their absolute breaking point. This is about the men who saved the USS Yorktown, not through luck, not through miracle, but through skill, determination, and an absolute refusal to let their ship go down without fighting with every tool at their disposal. And what happens next is absolutely remarkable. Before we dive into what these men actually did in those compartments, I need to know something. Where are you watching this right now? Are you in New York? Maybe Los Angeles? Could be Texas, California, or somewhere completely unexpected that I'd never guess. Drop your city in the comments below, because I genuinely want to know who's following these stories and where you're joining me from. And while you're down there commenting, hit that like button if this story about American naval resilience is absolutely gripping you. Show YouTube that you want more military history like this. If you haven't subscribed to this channel yet, what are you waiting for? We're releasing incredible stories constantly. Stories about American naval power, stories about battles that absolutely defined the Pacific War, stories that are going to blow your mind. Subscribe now and ring that notification bell so you never miss a new video. Now let's get back to what happened below decks, because the repair party's actions were absolutely extraordinary. The strike happened at 1:42 in the afternoon. The Japanese attack aircraft, a single-engine bomber attacking from altitude, had released its payload at approximately 13,000 feet. The Type 91 torpedo came screaming down, its descent taking just seconds before it penetrated the Yorktown's starboard side at the waterline, directly beneath the ship's flight deck. The explosion was instantaneous and absolutely catastrophic. The blast wave traveled through the water at nearly 5,000 feet per second. The impact created a hole approximately 18 feet in diameter along frame 58, opening up the ship's hull to the ocean itself. What happened in those first moments below decks was absolute chaos. The explosion ruptured fuel lines. It damaged electrical systems. It compromised the structural integrity of compartments that had been sealed and pressurized. But most critically, it created a massive influx of seawater rushing into the engine rooms. The forward boiler rooms were flooding. Steam and smoke filled the compartments so completely that sailors couldn't see their hands in front of their faces. Temperatures climbed to absolutely unbearable levels. The ship immediately lost significant electrical power, which meant communication systems began failing throughout her compartments. The repair party leader made an instantaneous decision. He had to seal the flooding. He had to stop the water from spreading to other compartments. He had to preserve what remained of the ship's buoyancy. But the compartments were already filling. The water level was rising at an alarming rate. The pressure in each flooding compartment was increasing, which meant the force pushing outward through the damaged sections was becoming absolutely immense. Traditional damage control procedures called for sealing bulkheads and isolating damaged sections. But this wasn't a traditional scenario. The officers coordinating damage control knew the torpedo damage was extensive. They knew that several compartments needed to be abandoned, but they also knew that the ship could still float if they managed the flooding correctly. The key was understanding the exact nature of the damage. What was flooding? What could still be salvaged? What compartments remained watertight? All of this information had to be gathered by men physically moving through the ship, checking compartments, reporting back to Central Damage Control. The repair party members detailed to conduct these reconnaissance missions were absolutely facing potentially lethal conditions. They were moving through smoke-filled passages. They were wading through rising water. They were checking bulkheads for signs of leakage, testing doors to determine if adjacent compartments had been compromised, mapping out where the flooding was actually coming from. Each man understood that if they missed something, if they failed to identify a compartment that was taking on water, it could mean the difference between the ship's survival and her sinking. One group moved toward the forward engine rooms where the initial flooding had been catastrophic. The water was already waist-deep in some sections. The compartments were filling faster than they'd anticipated. These sailors were establishing exactly how far the flooding extended. They were determining whether any equipment could be salvaged. They were assessing whether there was any possibility of stopping the water from progressing further aft into the engine rooms. Another group was working on establishing proper ventilation throughout the ship's damaged sections. The smoke and steam were so thick that visibility was essentially zero. If the repair party couldn't see what they were doing, they couldn't work effectively. They had to get air flowing through those compartments. They had to reduce the temperature and smoke density enough that their team members could actually function. The clock was absolutely ticking. Every minute that passed meant more water entering the hull. Every minute meant the weight of that water was pushing harder against the remaining structural elements. The repair party understood that they had roughly 30 to 40 minutes before the flooding would become absolutely irreversible. After that point, no amount of damage control would matter. The ship would be lost. The moment that torpedo detonated, every single member of the repair party understood exactly what they needed to do. This wasn't their first training exercise. These men had drilled for this scenario repeatedly. They knew the compartment layout. They knew the emergency procedures. But knowing something intellectually and executing it in absolute chaos are completely different propositions. The repair party mobilized within seconds. Officers were moving through the ship, accounting for personnel, organizing teams, establishing priorities. The Damage Control Central Station became the nerve center of the entire operation. Officers there were receiving reports from different sections of the ship. They were calculating water pressure in various compartments. They were determining which bulkheads could be sealed and which ones absolutely had to remain open for access. They were making decisions in real time based on fragmentary information and the fundamental requirement that they had to preserve the ship's structural integrity while ensuring their men didn't get trapped in flooding compartments. One critical decision involved the fuel tanks. The Yorktown carried thousands of gallons of aviation fuel distributed throughout her hull in multiple tanks. Some of those tanks were dangerously close to the torpedo damage. If fuel escaped from those tanks and combined with the flooding seawater, it would create an absolutely catastrophic situation. The repair party members assigned to check those fuel systems understood the risks. They understood that if any spark or flame reached that fuel vapor, the entire section of the ship would transform into a raging inferno. But they moved forward anyway, checking tank integrity, isolating fuel lines where possible, preventing fuel from spreading into flooded compartments. Another critical system involved the ship's pumping capabilities. The Yorktown had multiple damage control pumps distributed throughout her compartments. Those pumps represented the ship's best defense against continued flooding. If the repair party could get those pumps operational, if they could remove water faster than it was entering the hull, the ship might have a genuine chance at survival. But the pumps themselves required electricity to operate. The torpedo blast had damaged electrical distribution systems. Technicians had to physically move through the ship, assessing power availability, rerouting electrical current where possible, establishing priorities for which pumps absolutely had to have power restored first. The coordination required was absolutely staggering. You had sailors working on opposite sides of the ship, each trying to accomplish different objectives, each one absolutely dependent on information being accurately communicated to central damage control. A mistake in coordination, one team closing a bulkhead that another team still needed to access, could trap their fellow sailors inside flooding compartments. But the communication systems were failing. Electrical damage meant telephone systems were unreliable. Officers had to rely on runners, personnel physically moving through the ship, carrying messages between different damage control teams. The repair party leadership made a critical decision about resource allocation. They couldn't deploy people everywhere simultaneously. They had to prioritize where personnel were positioned. The forward boiler rooms were flooding extensively, but those compartments were already being progressively abandoned. The priority had to be on compartments that could still be saved. Compartments where damage control measures could actually make a measurable difference. Teams were positioned in the auxiliary machine rooms. Teams were stationed near the main engine rooms. Teams were deployed to critical junctures where their decisions would determine whether adjacent compartments remained watertight. Some of these sailors were carrying lanterns and flashlights because electrical lighting in the damaged sections had been extinguished. Others were carrying wrenches and tools needed to operate emergency valves and seals. Others were simply moving through the compartments, documenting what was happening, ensuring that the damage control central station possessed the most accurate information possible about the ship's condition. Every single one of them understood that they were racing against time itself. Every single one of them knew that the next 30 minutes would determine whether they were going to lose the USS Yorktown or whether they were going to accomplish something absolutely extraordinary. The fundamental challenge facing the repair party was preventing the flooding from spreading throughout the entire ship. The torpedo damage was catastrophic, but the hull compartmentalization that made the Yorktown such an advanced warship could now become her salvation. If they could maintain the integrity of the bulkheads separating the damaged sections from the rest of the vessel, They could prevent the flooding from becoming absolutely unstoppable. But executing that strategy meant doing something that pushed the physical limits of human endurance. Teams of sailors were positioned at critical bulkheads throughout the flooding compartments. Their objective was to seal any leaks before they could develop into torrential flows. The water pressure pushing against damaged bulkheads was absolutely immense. A single small leak could rapidly expand into a failure point. These sailors were equipped with wooden shores, heavy timber bracing used to reinforce bulkheads under pressure. They were also equipped with patches and waterproofing materials. Some were carrying cement and compound used for emergency sealing operations. One group was working on the starboard side where the torpedo had struck. The explosion had damaged bulkheads that extended upward through multiple decks. Water was attempting to penetrate through cracks and seams in those bulkheads. The repair party members were literally crawling along the inside surfaces of these damaged structures, identifying every single weak point, marking it, preparing to address it. Some of these men were working in water that was rising around them. They were working while temperatures climbed past 100 degrees Fahrenheit. They were working while steam and smoke made visibility almost non-existent. The repair party members working on the main deck levels faced different challenges. They were responsible for monitoring the bulkheads from the upper side of the damaged compartments. Their job was to watch for any water beginning to seep through and report it immediately to the damage control team. If water started penetrating through a supposedly watertight bulkhead, that meant the pressure inside the damaged compartment was building to a critical level. That information would allow the damage control officers to make adjustments, perhaps opening valves to equalize pressure, perhaps redistributing the flooding to different compartments with better structural integrity. Another critical operation involved the wooden shores themselves. These weren't lightweight materials. Some of these timber supports weighed several hundred pounds. Getting them positioned correctly against a bulkhead under pressure required absolutely precise coordination. Multiple sailors had to work in synchronization, positioning the shores at angles that would distribute force across the weakest points of the bulkhead. One shore positioned incorrectly could mean all the others would fail almost immediately once water pressure began pushing against them. The repair party also had to address the routing of flooding water. They couldn't prevent all water from entering the ship, but they could direct it toward compartments with superior structural integrity. This required opening and closing various valves and seals throughout the damaged section. Each decision about which compartments to allow flooding into was made based on careful calculation of the ship's overall buoyancy and stability. If they routed too much water forward, the ship would develop a dangerous bow-down angle. If they routed too much water aft, she might develop a stern-down condition that was equally devastating. One absolutely critical decision involved what they called the forward fire room. This compartment was already taking on substantial amounts of seawater, but it contained machinery absolutely vital to the ship's propulsion systems. The repair party faced an agonizing choice. They could seal this compartment completely, which would definitely save the surrounding sections from flooding, but would commit that compartment and anyone inside it to certain loss. Or they could keep it open for access, which meant maintaining a constant risk of the flooding spreading to adjacent spaces. The decision-makers chose to gradually flood the forward fire room while maintaining bulkhead integrity. It was a calculated sacrifice designed to save the ship. While one section of the repair party was focusing on containment and sealing, another group was engaged in an equally critical operation. They were working to restore the systems that would allow the ship to remain operational despite the catastrophic damage. The first priority was electrical power. The torpedo explosion had severed multiple electrical distribution lines. Main power to the damaged compartments had been lost almost immediately. But the Yorktown still had backup generators, and the repair party's electricians were racing to restore power to the sections that could still function. These electricians were moving through the ship with detailed circuit diagrams and understanding of the power distribution system that bordered on encyclopedic knowledge. They were tracing damaged cables. They were identifying which switchboards had suffered damage and which ones could still function. They were making decisions about rerouting electrical current along alternate pathways. Every decision they made had to be absolutely correct, because restoring power to a damaged line could cause catastrophic electrical fires. But without power, the damage control pumps couldn't operate, and without those pumps, the water would continue rising. The pump operations were absolutely central to the entire damage control effort. The Yorktown carried multiple independent pumping systems designed specifically for removing water from flooded compartments. Once power was restored to the electrical distribution system serving the pump motors, the repair party could begin removing water that had already entered the ship. But there was a sequence to this operation. They couldn't simply activate all pumps simultaneously, because that would overwhelm the discharge system. They had to coordinate pumping operations across multiple compartments to avoid creating pressure imbalances that would compromise the ship's structural integrity. One team was focused on the auxiliary pumping station. This facility housed multiple independent pumps that could draw water from flooding compartments and discharge it overboard. The auxiliary pump station had sustained some damage from the explosion, but it remained functional. The repair party members assigned to this station understood that they were running one of the most critical operations on the ship. Every gallon they pumped out was a gallon that wouldn't add to the weight pushing the hull deeper into the ocean. The coordination between Damage Control Central and the pumping stations had to be absolutely precise. Officers at Central were calculating the ship's stability moment by moment. They needed to know exactly how much water was in each compartment. They needed to understand the pressure conditions throughout the flooded sections. Based on that information, they were issuing instructions to the pumping stations about which compartments to prioritize and how aggressively to pump. If they pumped too much water from one compartment, the ship might develop a dangerous list to the other side. If they didn't pump enough, continued flooding would eventually overwhelm the compartments they were trying to save. The repair party was also addressing ventilation systems. The smoke and steam in the damaged compartments weren't just making conditions unbearable. They were actually interfering with damage control operations. The repair party members couldn't work effectively if they couldn't see more than a few feet in front of them. Sailors skilled in ventilation systems were working to redirect airflow, to open ventilation ducts that hadn't been damaged, to create circulation that would reduce temperatures and visibility issues. Another absolutely critical system involved the ship's ballast tanks. These large tanks, distributed throughout the hull, could be filled or emptied to adjust the ship's flotation and stability. The repair party's damage control officers were making continuous calculations about ballast redistribution. They were compensating for water weight in the damaged compartments by shifting ballast to other sections of the ship, attempting to maintain the Yorktown's overall stability and buoyancy. This was extraordinarily complex mathematics being performed under the most extreme pressure imaginable. The repair party members working on these systems understood that every single system they restored increased the ship's chances of survival. They understood that they weren't just fighting to save machinery and equipment. They were fighting to save the lives of their shipmates, and they were absolutely willing to push themselves to their absolute limits to accomplish that objective. At 2:10 in the afternoon, just 28 minutes after the torpedo strike, something absolutely remarkable happened. The flooding had been stabilized. The Yorktown was still taking on water through cracks and seams in the damaged sections, but the main inrush had been stopped. The repair party had successfully closed enough bulkheads and activated enough pumping capacity to prevent the flooding from becoming unstoppable. But this wasn't victory. This was merely reaching the point where the ship's survival became theoretically possible. The battle was far from over. The repair party members working in the forward boiler rooms were still facing absolutely catastrophic conditions. Those compartments had been progressively abandoned as water levels rose. The last sailors had evacuated only after ensuring that every possible system had been either shut down safely or transferred to remote operation from other compartments. But the boiler room spaces themselves were now completely flooded. The water was sitting at dangerous levels throughout the forward engine spaces. The ship's stability hung in a precarious balance between floating and sinking. The sailors working in the auxiliary machine room were now dealing with a different challenge. As the initial flooding had been contained, new problems were emerging. Some compartments that hadn't been directly damaged by the explosion were now beginning to take on water through seams that the pressure of the surrounding flooding was forcing open. The repair party had to move quickly, identifying these new leaks before they could develop into critical failures. Men were being deployed to specific locations with instructions to monitor for water infiltration and report any changes immediately to Damage Control Central. The ship's list was becoming more pronounced. Despite all the efforts at load shifting and ballast redistribution, the Yorktown was developing a noticeable tilt to starboard, toward the side where the torpedo had struck. The repair party understood that if this list continued to increase, it could eventually reach a critical angle where the ship would simply flip over. The shipyard engineers had calculated that the Yorktown could probably survive a list of up to about 10 degrees before stability became absolutely critical. Right now, the ship was approaching 8 degrees. Every adjustment the repair party made to ballast and flooding distribution was being calculated to keep the vessel from reaching that critical angle. The pumping operations were now running at absolutely maximum capacity. Water was being ejected overboard at a rate that was genuinely impressive. The discharge pipes were running so hot from the volume of water flowing through them that they were too hot to touch. The pump motors were working at absolute maximum RPM. The repair party members operating these pumps understood that if any of these systems failed, if any of these pumps seized up, the entire effort might collapse. They were running mechanical equipment at stress levels that no equipment was designed to sustain, and they knew that failure could come at any moment. The sailors working on structural shoring continued their absolutely exhausting work. Some of them had now been working in extreme conditions for more than 30 minutes. The temperatures in some compartments had reached levels that would normally cause heat exhaustion. The smoke and steam made every breath feel like inhaling fire. But they continued working, crawling along bulkheads, monitoring shore positions, making micro-adjustments as water pressure shifted and changed throughout the damaged sections. At one point, a report came from a compartment adjacent to the main flooding that a new leak had developed. The repair party sprang into action. A team of sailors moved immediately to that compartment, carrying emergency patches and sealing compound. They worked frantically to stop the leak before it could develop into a rupture. These men were working on pure adrenaline and determination at this point. They understood that this leak could be the difference between saving the ship and losing her, and they absolutely refused to let that happen. The repair party leadership continued making calculations. They were feeding information to the damage control officers about exactly how much water remained in various compartments. They were reporting on the status of every critical system. They were providing the moment-by-moment intelligence that was allowing the ship's commanding officers to make the strategic decisions about whether to continue fighting or whether to accept that the Yorktown situation was absolutely hopeless. But so far, the reports coming from below decks were encouraging. So far, the ship was holding. By 2:45 in the afternoon, the Yorktown situation had stabilized enough that the senior officers could begin considering operational decisions beyond pure survival. The ship had taken approximately 1,400 tons of water from the torpedo strike. She had suffered damage that would absolutely have sunk many other vessels, but she was still floating. she was still operational. She still had steam available to her engineering spaces. And all of this was because of what the repair party had accomplished in those first critical minutes after the torpedo strike. The men of the repair party would never receive medals for their actions. Most of their names wouldn't appear in historical accounts of the Battle of the Coral Sea. They would never be featured in photographs or newsreels. But they had accomplished something absolutely extraordinary. They had looked at a situation that appeared absolutely hopeless, and they had refused to accept that hopelessness. They had applied their training, their skill, and their absolutely unwavering determination to save their ship. They had succeeded when failure seemed inevitable. The repair party of the USS Yorktown represented something absolutely fundamental about American naval capability during World War II. It wasn't just about superior ships or superior technology. It was about sailors who understood their responsibilities. It was about men who were willing to face absolutely unimaginable conditions because they understood that their actions mattered. It was about professionalism and training and an absolute refusal to accept defeat. That's the battle no one saw. That's the victory that saved the Yorktown.